Hi, and welcome to the eCave. This is what I hope will be the last episode on my IBM 5150 PC. Well, at least for now. Will I get it going again? Well, step inside and see for yourself. Thanks for popping into my eCave. In this episode, I'm hoping I can finally add more memory to the IBM PC, at least max it out up to 640K and get it into its metal cage and case again, which is still waiting over there. As you see, I still have it on my test bench, ready to receive the extra memory. So on the last episode, I did show you some of the memory expansion cards from my secret ISA card stash. I decided to pick one that I think has 384 kilobytes of memory. And with that and the motherboard memory of 256K, I should be able to bring it up to 640K. However, before I do that, there's one unfinished business. Remember the IBM Monochrome Display Adapter, or the MDA, which was always beeping on every startup? Yeah, it's still here. Nah, something's still wrong with it. I've just received some SRAM chips in the mail, so I think it's time to diagnose that and work out what's wrong with it. So we can at least replace the SRAM chip and get it functional. Now, as you saw in my earlier video, I decided to run the advanced IBM diagnostics against the MDA, and it simply failed it and told me to replace it. No information on which memory location was faulty. The IBM service philosophy at the time was simply to replace cards and dispose of the faulty ones. Today, that's not an option. These cards are hard to come by, plus they cost money, so it's well worth the effort to try to fix it up. Now, after the advanced diagnostics didn't tell me anything, I didn't know already, I used the super soft diagnostic ROM, and I was hoping it would call out the faulty memory location. And as you saw in episode 3, or part 3, I thought it was calling out bit 7 in memory location B0001. That didn't make any sense at the time. I've revisited that video footage and realized that it was actually calling out memory location B0801. Now, B0801 is memory location 2049 on the screen. But how can that be? Well, the MDA driving the 5151 monitor has 25 lines of text with 80 characters. 80 by 25 is 2000 character location. So why is SuperSoft Diagnostic calling out a memory location beyond the 2000? Each character only needs 1 byte, doesn't it? Well, it's because in addition to each character, we have another byte which dictates how that character is to be displayed. This is called the attribute byte. The MDA can display highlighted, blinking, underlined, and even characters in reverse video. In order to do that, IBM doubled the memory of the MDA card from 2000 to 4000 memory locations. Then they decided that every even memory address would contain the byte for what character to display, and every odd memory address would contain the attribute byte for how to display the character on the screen. So when this diagnostic calls out video memory location 2049, which is an odd number, it tells me straight away that there's an issue with one of the SRAM chips which stores the attribute byte in that location. So is there a way to confirm that by any other means? Well, I think so. A few years ago I downloaded a copy of Sam's Computer Facts, which is a repair guide for the IBM PC 5150. In the repair guide, Sam has a chapter on the MDA and even a schematic diagram as well. He also has a simple basic program which you can use to fill the screen with a character with most of the attributes applied to see if any of the attributes are missing, and if so, where. This is what you can see when you run the program. As you can see, Sam uses the character star and then has it blink, highlight and underlined. Well, we can see the underline stops 3/4 along line number 13. It's distracting to have all this blinking, so let's run it again without that and see just the underlined character star. As you see, we can see where the underline stops and we can work out the character location for that. Now we can calculate the location based on this information. We have 13 lines with 80 characters, which is 1040. If you subtract from that the 16 last characters, which are not underlined, you get 1024 character position. We have to double that to include all the attribute bytes as well, because the character byte is at an even address and the attribute byte at the odd address. By doubling 1024, we get 2048, which is the character position for the first star without an underline, because the next one is the odd memory location, which should contain the attribute for the underline. That is, of course, attribute location 2049, which is the same location called out by the Supersoft diagnostic ROM. This confirms that our issue has to do with the attribute memory. We can see that the MDA card has 8 SRAM memory ICs labeled U8 to U15. Each memory IC stores 4096 bits, organized as 1024 by 4 bits. The 8 SRAM ICs together therefore form the 4K video RAM. 4 of them store the bytes for the characters and 4 of them store the bytes for the attributes. But which of the 4 storing the attributes is the faulty one? Well, thankfully, Sam's Computer Facts repair guide has a section on the IBM Monochrome Display Adapter which details which ICs handle which attribute code. So let me show you. As you see, it's U8, U9, U10 and U11 which store the character attribute bytes. Based on that, it's clear that we either have U10 or U11, which is failing. Given that the memory location we have failing is in the lower part of the screen, I'm guessing we have to replace U10. So that's what I will do next. So let's get that happening. Well, I'm ready to desolder the U10 chip. As you can see, I've labeled them, and I'll put a wide line between the legs of the one I want to desolder. But before I desolder it, I'm going to reflow the legs to make it easier. So I'll use my soldering iron, and hopefully that will make it easier to desolder it with a desoldering gun. I managed to desolder the legs, and they are pretty much loose on this side, but on the other side, because these are through-hole boards, it's a bit harder. So I'll have to heat up the chip to get it out. But all the pins were bent sideways, so it made it a little bit harder. Just applying some heat. So I can get it out with ripping any pads. But out it comes. I'll put a socket in there. I'll clean it up and put a socket so we can take it out again if we need to. I think it's come out pretty good. Let me show you. As you can see through all the holes, and all the parts seem to be intact. Let's see the other side. Oh, where is it? Oh, there you are. The other side looks good as well. Yeah, I'm happy with that. I'm soldering the socket in. I don't have any overhead microscopes or camera, so I'll just show you doing this. First one, and you can imagine all the rest. Well, the socket's soldered in. Doesn't look half bad. Well, if you see it, well, you can barely see which one was taken out. So, not too bad. Since I have the retro tester, I might as well test this 2114 SRAM in it to see if it's actually okay. It comes up with SRAMs. That seems to be the default when you power it on. So let's select that and go to 2114 1K times 4. Oh, it's passed. So our diagnosis has been wrong. I'll test one of the new ones. And we'll definitely put that in and try the adapter in the IBM PC. Let me see. Yeah, let's not sacrifice this one if it's working after all. So it might be the U11. Or it might be something entirely different. Well, we'll have to find out. So that's one of the new ones. It's working. Anyway, let's put the new one in. It should slot in nicely into the socket. Gotta bend the legs a bit. Did that help? I believe so. Well, let's put in the PC and see if anything's changed. Yeah, it tested the faulty one, or what we suspect is a faulty one, tested fine. Bugger. I put the MDA adapter back into the motherboard with the new SRAM which tested good in the Retro Pro tester, but also the old one. So maybe there's something else wrong, but we can only try, see if it works. You can see the screen there. No beeps. Did you hear that? There was no beep. It looks like it's fixed. I'm surprised. Yep, that's a normal beep. It's booting from DOS, which is a good thing. I haven't had any problems with the diskette drive since I fixed them up and tracked aligned one of them and weeded out the one that was just giving me lots of problems. So let's go to the B drive where I have the basic program. Yeah, there we are. Basic JA, the second last one. And TTRIB.pass. If that works, then we're in good territory. We're home. Another MDA has been saved from being thrown away. Fantastic. So it was U10 after all. I don't know why the retro tester thinks it's fine, but this is excelente. I'm happy with that. That means the other one, the Taxon, I have some spare one. Great. Now it's just the memory adapter, the 384K. I've got to do some dip switch settings to tell the motherboard it has 640K and put it in and see what happens with that. So let's do that next. This is the 384K memory adapter I'm planning to put into the PC. It looks like the top row has two 56K bit memory chips, and the two lower rows have 64Ks. So two 64Ks plus two 56K, that's 384K. Now, I showed you the wrong adapter when I was doing the intro. I was wishfully thinking I could use this one, an Australian product in a Wangaratta made PC, but it only has two 64K rows, so 128. But let's go with this one. Thankfully, I've got the manual for it here. And if we go and check the switch settings on this adapter, let me find the page. There are 8 diff switches, and the first 2 designate the base memory of the PC we're putting it into, i.e. where this should start. And in our case, they should be both on because our base memory is 256K. And if we look at that, yeah, 1 and 2 are on, which is good. Next is diff switch number 3 and 4, which designate how much memory is on that card. And based on our configuration, 384K, switch 3 and 4 should be on and off. And I believe that's the case here, on and off. Then we have switch 5, which according to this should always be on, and I think 5 is definitely on.
And then we have the parity check diff switch, which is diff switch 6. And that should be enabled because we have parity check on the motherboard, and 6 is enabled on. And then we have 7 and 8. Well, they're not being used, so it doesn't matter what they are. Yeah, we'll leave them as is. Next, we need to do the motherboard switch settings. And to do that, we need to use the hardware maintenance service guide and go to the switch setting supplement. And in here is a table detailing how much memory we have. And in total, you can see on the left column all the total memory. We are planning to have 640K, so we have to go all the way to the last entry, 640K. It tells us switch 1 and switch 2 on the motherboard should have those settings, but it depends on the PC. So you have a 16 to 64K motherboard or a 64K to 256K. And that's the column we use. And those are the switch settings. And I'll set them on the motherboard. I won't show you that as simple setting of the diff switches. And then we'll put the card in. It's not that complicated, I guess. Probably doesn't matter where it goes. It's a bit hard doing this single-handed. And then we'll power on the PC once I've done the switches on the motherboard. It's time to power on and see if we have 640K. I'm sitting here on the right hand side. I've moved the keyboard here, but I'm also capturing the output from the MDA adapter, so you'll be able to see that clearly. All right, let's rock and roll. I've got the advanced diagnostics in the A drive because I will accurately test the memory, so if it works. Power on! No beeps, and there's the blinking cursor, which is a good sign. It's taking a bit of time. I'm guessing that's because it's testing all the memory in the post routine. Well, we'll find out soon, I guess. Interesting, it's not counting up. Maybe that's the BIOS revision. Ah, we're there. So I'll do 0 system checkout, and I'll skip ahead because it tends to take a while. Oh, it's back. 640 kilobytes of memory. Fantastic. And yes, that's correct. Run test one time. I think we should test the memory, because at the end of the day, I don't know whether the post has done a proper job. All right. I'll skip through it and we'll see what happens at the end. Oh, it tested everything fine. I'm surprised. The 384K memory expansion card tested good. Fantastic. Let's put in DOS and see if it boots from DOS and it's happy. So we'll take out the advanced diagnostics, put in the DOS diskette, do a soft boot. And we're back to 1980, 1st of January 1980. Fantastic. Let's do a check disk. And we're reporting 655,360 bytes of memory. Fantastic. Looks like we're in business. Yeah, I think it's time to put this motherboard back into its cage. So I'll do that next. I'll probably fast forward through me doing that. You've probably seen that a number of times. So let's get to it. Well, we've come to the end of this series on the 5150. It's finally back together and working as it should with the 2 floppy drives. Everything appears to be fine. Of course, what's left is the monitor and the keyboard, but that's another adventure lying ahead. I'm quite happy with the 5150. I'm not planning to upgrade it or make it go faster. I have another one, and I think I've got about 4 XTs which I've yet to restore as well. So there's plenty of work ahead. This episode will probably be the last one for this year, as the family is heading overseas. And we won't be back until probably in January or mid to late January. So we'll see what I can do when I get back. But I've learned a lot, and that's been fantastic. I did put the SRAM chip back into the probe tester, and I did scope all the output pins, i.e. from 11 to 14. And what I've noticed is that one of the outputs has a lower output voltage than the other 3. So I'm guessing that's what caused it to fail in the MDA adapter.
whereas it seems to work in the Retro Tester Pro. It's interesting that the voltage level seems to have had that influence, that the post routine and all the tests within the IBM PC failed it. But at least now we know. So, thanks for watching this series, and until next time, goodbye.